Hello everyone, welcome back to Express VTU for all. In this video, we are going to solve a very important problem from Module 1 which is based on eigenvalues and eigenvector. So the question is, determine the eigenvalues and corresponding eigenvectors for the matrix. This is a matrix which is given here. Let's solve it. First we find eigenvalues. So how can we find the eigenvalues? We can find it by a minus lambda into I whole determinant which is equals to 0. So we can consider this is a matrix which is given here, and this is 3 cross 3 matrix. Lambda is represented here eigenvalues which we are finding, and I is identity matrix. So what is identity matrix? Identity matrix for 3 cross 3 which is 1 0 0 0 1 0 0 0 1. This is the identity matrix for 3 cross 3 matrix because 3 rows are there and 3 columns are there. That's why this is 3 cross 3 matrix. So now let's solve it. So first is we are finding lambda into I, nothing but lambda multiplied by identity matrix which is 1 0 0 0 1 0 0 0 1. So when you multiply it, it become lambda 0 0 0 lambda 0 0 0 lambda. So now we are finding a minus lambda into I. So a matrix is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 and minus which is lambda 0 0 0 lambda 0 0 0 lambda. So when you separate it, it become 8 minus lambda. So 8 minus lambda minus 6 minus 0, this is minus 6, like that 2 minus 0 is 2, and this is minus 6 minus 0 which is minus 6, like that 7 minus lambda, and this is minus 4 into minus 4 minus 0 which is equals to minus 4, like that 2 minus 0 is 2, minus 4 minus 0 which is minus 4, and 3 minus lambda, so 3 minus lambda. So now what is our next step, which is determinant of a minus lambda. This is our a minus lambda, so we take the determinant of this matrix. So now we can expand it along this one, 8 minus lambda to this. So expanding the determinant. So 8 minus lambda, and this goes. So minus 3 minus lambda into 7 minus lambda minus 4 into minus 4. So we can write it as 7 minus lambda into 3 minus lambda minus, this is minus 4 into minus 4, this is plus 4, and separate it becomes 16, like that, plus this is minus, so this is 1 comma 2, so this is odd, that's why it become positive. So 6, this goes minus 6 into 3 minus lambda, so minus 6 into 3 minus lambda, and this is 2 into minus 4 which is minus 8, so this is plus 8, like that. Now expanding along with column 3 which is plus 2 into this goes minus 4 into minus 6 which is 24, so 24 minus 2 into minus 7 into lambda, so 2 into 7 minus lambda which is equals to 0. So when you solve it, it becomes minus lambda cube, so lambda minus lambda cube plus 18 lambda square minus 81, this is 81 lambda which is equals to 0. So when you take it lambda from this equation, it becomes minus lambda which is equals to lambda square minus 18 lambda plus 81 which is equals to 0. So when you take it 0 this side, it also becomes 0. So one condition is there, our one eigenvalue lambda 1 equals to 0. And now solving our this equation, quadratic equation, which is lambda square minus 18 lambda plus 81 equals to 0. So our quadratic equation is lambda square minus 18 lambda plus 81 equals to 0. So now we can divide it as lambda square minus 9 lambda minus 9 lambda plus 81 equals to 0, because this is a multiple of 9 9 81, so this is 81. So when you take it this term as lambda, which becomes lambda minus 9, like that we take minus 9 from this term, it becomes lambda minus 9 9 81. So lambda minus 9 and lambda minus 9 two factor are there, so lambda equals to 9, we can consider it as. So our eigenvalues are which is lambda 1 equals to 0, lambda 2 equals to 9 and lambda 3 equals to 9. These are our eigenvalues. Now we are looking for our eigenvector. So eigenvectors. So first we find the eigenvector for lambda equals to 0. So for solving this one, we are solving a into x equals to 0. This is nothing but x is eigenvector. So what is the value of x equals to? This is nothing but x, y and z. This is our eigenvector. We need to find the value of x, y and z. So what is A matrix? A is nothing but 8 minus 6 2, 8 minus 6 2, minus 6 7 minus 4, like that 2 minus 4 3, and multiply by our eigenvector which is x, y and z, which is equals to 0. So multiply it. This is our column and this is our row. So multiply column with row. So now multiply it. So x multiplied to this row, this is 8x minus 6x plus 2x, like that, plus this is y minus 6y minus 6y plus 7y, this multiply this, and plus minus 4y, like that, z which is 2z minus 4z plus 3z. So when you solve it, it becomes 8 and 8x plus 2x, 10x minus 6x, which equals to 4x, like that, 4x minus 3y plus z equals to 0. So this is the equation we are obtaining from by multiplying our A matrix to the eigenvector. So now solve this equation. So if y equals to 2 and z equals to minus 2, then x equals to 2. Let's see how it comes. If I put y equals to 2 and z equals to minus 2, we can satisfy this equation. Let's see. If 4x minus 3 into y value is 2, we are assuming there, and z value equals to minus 2, which is equals to 0. So this is 4x minus 6 minus 2, which equals to 0. So what possible values are there of x? So it becomes 8, because minus 6 and minus 2 is, so 4x minus 8 equals to 0. So what are the possible values of x to get? It's 8, that's why it is equal to 0. So we can easily assume that if x equals to 2 here, then it comes 0, means 4 into 2 minus 8 equals to 0. So this is 8 minus 8 equals to 0. So we can easily see that x value is 2 here, that's why it becomes 0. So our x value is 2. So for lambda equals to 0, our eigenvector for lambda equals to 0, which is 2, 2 and minus 2. This is our x, y and z. Now we are finding eigenvector for lambda equals to 9. So for lambda equals to 9, what are the eigenvectors? Which is for lambda equals to 9, we are solving a minus 9 into I into x, which is equals to 0. Here lambda value is equals to 9, that's why we are solving this. In the first case, lambda equals to 0, that's why we can easily directly solve it. So what is I? I already explained you, which is nothing but 1 0 0 0 1 0 0 0 1 identity matrix, and A value is the determinant which is given. Sorry, A value is the matrix which is given in the question, which is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 and 3. Now multiply 9 with the identity matrix, which is 9 into 1 0 0 0 1 0 0 0 1. So this is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3, and multiply it, it becomes 9 0 0 0 9 0 0 0 9. So when you separate it, it becomes 8 minus 9, which is equals to minus 1, minus 6 minus 0, which is minus 6, and this is again 2, like that, minus 6 minus 0, which is minus 6, and 7 minus 9, which is equals to minus 2 and minus 4 as it is, like that. 2 minus 0 is 2, minus 4 into, sorry, minus 4 minus 0 which is equals to minus 4, and 3 minus 9 equals to minus 6, and multiply our eigenvector which is x y z which is equals to 0. So when you multiply it, like same where I explained in the first case, which is lambda equals to 0, our equation become, it gives x plus 6y minus 2z equals to 0. So now we are solving like this for the first case. What are the possible values which are required to satisfy this equation? So two cases are there. If y equals to 1 and z equals to 0, then what is our x value? X equals to minus 6. Let's solve it. If I put y equals to 1 in this equation, which is 1, sorry, x is like same as it is. If y equals to 1 means plus 6, and 0 equals to minus 2 into 0 which is equals to 0. If x value is minus 6 means minus 6 plus 6, this is 0, equals to 0. So this is cancel out, it becomes 0. So we can clearly see that if x value equals to minus 6, then it will satisfy this equation. So our first eigenvector for first case, which is becomes minus 6, 1 and 0. This is the value of x, y and z. Now our second case is, this is our first case. Now second case is, if y equal to 0, z equals to 1, then x value equals to 2. If I put x equals to 0, sorry, y equals to 0 here, z equals to 1 here, then what is the x value which is equals to 2? Now let's solve it. X plus 6, y value is 0, so 0 minus 2 into z value is equals to 1, it becomes 0. So x plus 0 minus 2 equals to 0. So what are the possible values of x? Then this equation becomes 0. It means, as you can clearly see, that x value equals to 2, then it satisfies this equation which becomes 0. So our second eigenvector is 2, 0 and 1. This is x value, this is y value and this is z value. So we can write it as, for lambda equals to 9, our eigenvector is minus 6, 1, 0 and 2, 0, 1. And for lambda equals to 0, our eigenvector is 2, 2, minus 2. So like this, we are finding all the cases which is given in this question. Thank you for watching our video. Please subscribe Express VTU for all.